What is parallelogram law of vector addition? When we go through the statement of parallelogram law, we find three important things there. What are like vectors? Two vectors represented by two sides of a parallelogram should be like vectors. What are like vectors? Like vectors are those vectors which are of same nature, just like f1 and f2 represents two vectors of nature of force. So these are like vectors. Similarly, v1, v2 are two vectors representing velocities. So these are like vectors. But if we consider one to be f1, which is force, and another to be v1, which is velocity, then these two vectors are not like vectors. So these two vectors cannot be taken into consideration for parallelogram law. Now, second point is that they should act simultaneously on the same body. The two vectors represented by two sides of a parallelogram, these vectors act on the same body at the same time. Now here simultaneously means at the same time. Now these two vectors represented by two sides of a parallelogram are taken in same order. We'll draw some figures and we'll see what these things mean. Let us consider we have two vector, one being P and another being Q. These two vectors are acting at an angle theta. So this is P vector, this is Q vector acting at an angle theta. So now we have to draw a parallelogram. Now this is the parallelogram A, B, C and D, where AB and AD are two sides of a parallelogram, P being one vector, Q being another vector. Now by parallelogram law of vector addition, P and Q should be in same order, the third point. So we can represent this vector Q with this vector. So this vector and these vectors are equal vectors because their directions are same and the magnitude are same because the opposite sides of a parallelogram are equal. This side and this sides are equal. Now we have taken vector P and Q by two sides of a parallelogram in same order being anti-clockwise. So this criteria has been followed. Let us extend this line and we draw a perpendicular from point C. Let this point be E. If this is theta, this is also theta. These two angles are corresponding angles because these two sides are parallel. By parallelogram law of vector addition, what does it says? If two vectors, vector P and vector Q, are the two sides represented in same order, being same order, then the diagonal connecting them is the resultant of these two vectors. So here resultant R is equal to vector P plus vector Q. Let phi be the angle made by resultant with vector P. Now if we consider this triangle A, E and C, triangle A, E and C, It is a right angle triangle, so you can apply Pythagoras theorem here. So AC square is equal to AE square plus EC square. Here the magnitude of resultant is represented simply as R. For P it is simply P, and for Q it is simply Q. Now we need to find AE. We know AE is equal to AB plus BE, and even we have to find EC. What is EC? So here if we take triangle BEC, if we take triangle BEC, then by sine theta, which is P by H, in this right angle triangle BEC, sine theta is P by H. So P is EC and hypotenuse is Q vector itself. Q is the magnitude of the vector Q. So EC is equal to Q sine theta. So EC can be represented as Q sine theta. Again, if we take this triangle BEC, this being a right angle triangle, by cos theta, which is B by H, base by hypotenuse, base being BE and hypotenuse being Q itself. So BE is equal to Q cos theta. So this becomes B. So this becomes Q cos theta. So AC is represented by R square is equal to AE. So AE is AB plus BE. So P plus Q cos theta whole square. This is AE. P plus Q cos theta plus Q square sine square theta, this whole square. So R square is equal to P square. If we square these terms, P square plus Q square cos square theta plus 2PQ cos theta plus Q square sine square theta. R square is equal to P square. We can find the common terms here, Q square. So we can write Q square cos square theta plus sine square theta plus 2PQ cos theta. We know cos square theta plus sine square theta is 1. So R square is equal to P square plus Q square plus 2PQ cos theta. So R can be written as P square plus Q square plus 2PQ cos theta under root. Now this is the magnitude for the resultant of vector P and vector Q. Now we know the resultant is root under P square plus Q square plus 2PQ cos theta Now we need to find the angle of resultant with vector P, that is phi. So if we take this triangle AEC, this is a right angle triangle. So if we take if we take tan phi, which is equal to P by B, perpendicular by base, perpendicular being Q, this EC, which is Q sin theta, which we already found, by B, the base is AE, AE. So AE is again P plus Q cos theta. So phi can be written as tan inverse Q sin theta by P plus Q cos theta. So this angle is the resultant. So this angle is the angle made by resultant with this vector. Now we know R is the magnitude of the resultant and phi is the angle made by resultant with vector P. Now we will see some cases. If theta is equal to 0 degree, then sine 0 degree is equal to 0 and cos 0 degree is equal to 1. So resultant will be P square plus Q square plus 2PQ, and this cos theta will be 1 because theta is 0 degree. So this can be written as P plus Q whole square. So resultant is equal to P plus Q. If two vectors are in the same direction, this being P and this being Q, theta is 0 degree, the resultant is in the same direction. The magnitude of the resultant is simply arithmetic sum of magnitudes of two vectors. Now the resultant is in same direction. We can use this formula and prove it. So phi is equal to tan inverse. We know Q and sine theta. Sine 0 is 0. So it becomes 0. The whole things become 0 plus P plus Q. Phi is tan inverse 0. So phi is 0 degree. So resultant is in the same direction. If theta is 180 degree, then we know sine 180 is 0 and cos 180 degree is minus 1. So R equal to P square plus Q square plus 2PQ minus 1, which will be equal to P square plus Q square minus 2PQ. So this is R equal to P minus Q whole square is equal to P minus Q if P is greater than Q. This will be positive. If Q is greater than P, then this will be negative. If two vectors, vector P and vector Q, are at 180 degree, means they are in opposite direction. Theta is 180 degree. So the resultant will be in the direction whose magnitude is greater. If P is greater than Q, the resultant will be in this direction, where resultant magnitude will be arithmetic difference of P minus Q, where P and Q are the magnitudes of vector P and Q. If Q was greater than P, then the resultant will be in this direction, whereas the resultant magnitude will be equal to Q minus P. Or we can use this formula to find the resultant angle. So phi is equal to tan inverse Q sin theta. So Q sin theta, sin 180 is 0. So whole things become 0. 0 by something is 0. So phi is equal to 0 degree. Now 0 degree means with respect to first vector. The first vector is P. If P is greater than Q, then the resultant will be in this direction, in the P direction. If Q is greater than P, then the resultant will be in this direction. If theta is 90 degree, then we know sine 90 is equal to 1 and cos 90 degree is equal to 0. So the resultant will be P square plus Q square plus cos 90 is 0. So it will be 2PQ into 0 will be equal to P square plus Q square. That means R square is equal to P square plus Q square. So if two vectors, vector P and Q, are at 90 degree with each other, then what we can do, we can put Q here because these two vectors are equal because direction are same and magnitude is also same. Then this vector will be the resultant vector. We kept this vector here in order to be in same order. So this is also 90 degree. So we know the magnitude of resultant is equal to P square plus Q square under root as a Pythagoras theorem. Now how do we find the angle? Obviously, if this angle is 90 degree, this angle has to be less than 90 degree. If this phi is the resultant angle with respect to P vector, then we can find using this formula. Let's see. So phi is equal to tan inverse Q sine 90, which is Q sine 90 is 1 plus P plus Q cos 90. Cos 90 is 0. So phi is equal to tan inverse Q by P. Or simply we could have done tan phi is equal to P by B. P is this perpendicular being Q and B being this base which is P. So phi is again tan inverse Q by P. How do we construct parallelogram vectors? Suppose there are two vectors, vector P and vector Q, and theta is the angle between them. How do we construct the parallelogram vectors based on these given data? What we do, we take a point. If this vector magnitude is 5 unit, if we take 1 centimeter is equal to 1 unit, then to represent 5 units we need 5 centimeters. So we draw 5 centimeter line segment here. This is P vector. Now if we know this angle, let it be 45 degree. Now we put the center of the protector here and draw a line which is 45 degree. Now let the magnitude of Q vector be 6 units. As we know 1 centimeter represent 1 unit, 6 units can be represented as 6 centimeters. So we'll measure 6 centimeters with compass. So now we'll measure 6 centimeter with compass. One end has to be at this point and other end makes an arc or cuts this point at 6 centimeter, this being Q vector. What do we do now? We draw a line parallel to this vector P vector. Now this line has to be of same length, 5 centimeter. So we make a point where 5 centimeter falls. From this point to this point we connect with a line. So these two sides are the opposite sides of a parallelogram, and these two sides are the opposite sides of a parallelogram. These two sides are equal and these two sides are equal. Hence this P vector and Q vectors are the two sides of a parallelogram, and now we have successfully constructed a parallelogram.